In the final part of my lecture on sampling, I shall summarise what we've learnt in this lecture. First of all, we learnt that the sample mean is an unbiased estimate of the population mean, but the sample standard deviation is an underestimate of the population standard deviation. So to get the best estimate of the population standard deviation, we have to take the sample standard deviation and multiply by the square root of ns over ns minus 1. That's known as Bessel's correction. If you want to do that in Excel, then if you use the functions var_p and stdevp, they calculate the sample variance and standard deviation if you give them just the sample data. Then you'd have to apply Bessel correction manually. If you use the functions var and stdev, they estimate the population variance and standard deviation based on the sample data. In other words, they include the Bessel correction in that formula. In fact, if you use the descriptive statistics option under data analysis tool in Excel, that also gives the variance and standard deviation based on var and stdev, and if you carried out the exercise that I suggested in the previous lecture, that explains why the standard deviation calculated by the descriptive statistics tool was 12.6. When you calculated it by hand, it gave 12.0. The difference was just Bessel's correction. We also learnt that the standard error of the mean is a measure of the likely difference between the sample mean and the population mean, and the standard error of the mean can be calculated as the population standard deviation divided by root ns, or estimated from the sample standard deviation divided by root ns minus 1. And you can deduce confidence intervals from the standard error of the mean using the normal distribution if we've got large samples of more than about 30, or the t-distribution for small samples of less than 30. And remember that the standard error of the mean is a measure of precision, not of accuracy. Finally, we saw how averaging several measurements can improve precision, but of course it doesn't do anything for accuracy. So that's the end of the third lecture in my series of statistics for nuclear medicine.